Well, thank you for coming. My name is Amir. I work for InterSystems for 15 years. I started in Brazil, then moved to Chile, and now I'm here. So my English is a little bit weird. If you can't understand what I'm saying, please just ask. Okay, I'm used to it. So you know IRIS, right? IRIS is this platform that can help us with this specific use case that I like to classify it with, like intelligent interoperability. That's what we are going to see in this session. Extreme data ingestion, that's about ingesting large amounts of data of records per second while allowing applications to query this data in real time. And we are also a multimodal SQL database for your applications. Well, let's dive into the intelligent interoperability. Imagine there is this application, right? And no application out there works alone in the world, right? We have to connect to services in the cloud. We have to connect to services in-house, external services, partner services, lots of other applications that we have to interoperate with. And many of you already know IRIS, right? And all the connectors that we give you to connect to these external systems, the process orchestration capabilities that we have that allows you to draw your process, predictive operations that allows you to call machine learning models to make smarter decisions, workflow. All this is on IRIS. And IRIS can help you, for instance, connect your application to this legacy system you have, let's say SAP, and remember legacy is legacy because it works. It's been there for a while. It doesn't mean it's a bad system. It's there for a while. It's been working, and you need to talk to that system. And it may not have REST interfaces. It may not be easy to connect to. So we have connectors for helping you with that. So imagine that problem is solved, and now IRIS is this service that you call to talk to your backend, in this case SAP. So there is this orange line you see there. That's the connector working with SAP. Keep that in mind. That can scale to many nodes, right? If you need too many people calling that service, it will scale independently of other servers you may have. And your application may end up calling other applications, other IRIS services that is talking to other systems, and you can have these systems on different boxes scaling independently on a microservices architecture. You can have everything on a single box or on many boxes, that's your choice. But the applications start to get complicated, right? The same application to get a single thing done, it starts calling several different services. It's complex. It's a lot of latency. It's a lot of complex orchestration complexity inside that application. So we can help you with that too. We can give you process orchestration. It's just a service aggregation layer that will expose a new REST service that is calling those other services using our business orchestration capabilities that's very low code, that's very easy to configure. And if you have dynamic business rules, you can use our business rules engine to code that, and they can keep changing with the business without anyone having to put their hands on the code. You'll probably be calling other systems, right? So you need data transformations, and you can use the data transformations designers to match data structures between systems and fix coding systems like this is MF, other, and this is 1, 2, 3. We can do all of that here, call functions, apply transformations to the data. And all of this is on an audit trail. You can store months and months of audit trail. Everything you're doing is registered here. So here on this screen, you can see like a service that just started a call, a process started, and it talked to a master patient index, got the patient identification. This is just a demo, right? But got the patient identification IDs on many systems, and then start talking to all the other systems. You can see the data, time, and millisecond of all these calls. You can click on the message, see the content. You can search by the content. So when something goes wrong, it's very helpful to have such audit trail, right? It's good for the developers, it's good for compliance, it's good for everything. So everybody's happy, the system is working, the interoperability is working, and I have talked to the first system, got that data, talked to the second system, aggregated that data, talked to the third system, and I got the response. I have all this data in my hands, right? Already normalized. So why throw that data away? I have all this data in my hands because I just answered to that REST call, but I don't have to throw it away. I can store it on a normalized data lake that's on IRIS, on another box. And why is this good? Because I can give you out-of-the-box traditional analytics. You can see your business in real time, what's going on. You don't have to do ETL, fetch the data, build a data mart, and then build a dashboard on top of it. It's out of the box. I have all the data in my hands. I just store it, and the data lake is always current. But we don't have to stop there, and that's the intelligent part started to appear. We don't have to stop there. There are many other use cases. Depending on the industry you're working on, you want to do churn prevention, you want to do customer life cycle, you want to do, I don't know, risk modeling, predictive maintenance. And all these use cases require accessing all the data, normalized from all your systems, applying machine learning models, and generating a model. So that's when the normalized data lake also helps you with, because you can pick your tool. In this case, I just put Spark in there, but it could be Python with machine learning libraries, could be R. You choose whatever tool you want, freedom of choice, as you saw in the keynote, and you build a model. Let's say you build a model, decision tree or random forest, and you export this model as a PMML. PMML is an XML file that's used to export models. So I can build a model using Spark and run it on IRIS or on my Java code or whatever. Whoever supports PMML can use machine learning models, and IRIS supports PMML. So let's put that model there. So now my business process is making smart decisions because I'm using the machine learning model exported during my decision process and making smart decisions. But let's say we are preventing fraud, we are detecting fraud, right? And people adapt. They realize that, okay, he's not allowing that anymore. They change. They will find new ways to fraud your system. And we have new data coming all the time. The data science doesn't have to ask it, okay, send me that CSV file again, like 6 months passed, let's upgrade that model, it's not performing well. So it doesn't need to be like that. The data scientist can just decide, okay, let's train this model again, let's keep monitoring it, let's see if the model is degrading, if the decisions, if it started to stopping predicting models, predicting frauds, and you come up with a new model, right? And you can just plug it in or compare. You compare two models to see how they both perform. You can plug into IRIS, and this workflow keeps going on. And people don't have to ask CSV files, do ETL, you know. The teams are working together, the data science team, the application engineers, they are working together. You don't have to touch your legacy to apply a machine learning model. I don't know if you know or if you have tried that, but sometimes you're going to see a decision tree. It's hundreds of ifs. A regression, a linear regression, it's like an equation. And you have to code that by hand sometimes on your legacy. And that's too invasive or too complex if you have to put together lots of technologies, different technologies to help you with. So IRIS can help you with this workflow in so many ways. So the data is current all the time. It's always available for the data scientist. PMML can be used to plug your model in very quickly, and it works on the cloud if you want it. So that was intelligent interoperability. And I have a demo for you. The demo we saw on the keynote very quickly. Let's explore it more in detail. So what the demo is about. When I started building this, I decided to do this fraud prevention demo because everybody understands this, right? Everybody has a credit card. Everybody knows what a fraud problem is. So there is this point of sale, and I'm swiping my card, and there is a service layer that's running IRIS, and it's talking to your legacies, like it's talking to the banking core application, it's talking to the customer services. Why? Because maybe you're traveling and you told me in advance, like, I'll be in China and please let the transactions go through. It's me, I'm there. Or I'm buying, like the example we used on the session yesterday, I'm buying $1,000 of McDonald's because I'm throwing a party for my kids there. I don't know. So you can whitelist your transactions in advance. So I have to talk to the banking core application, to the customer service application. I have to call the machine learning model to predict if this is a fraud or not. And after I'm done, I have to take all this data and store on a data lake. And then my data science team can work and always work with the current data, come up with a new model, and plug it in on the production. And these workflows keep going. So let's see that working. So this is running on containers. So I have several containers started here. I will not spend much time there. There is a session after this one, a flash talk over there with very little chairs. I was telling Andreas that I'm hoping to cause him a problem. There will be no place for people to sit. I'm hoping, so help me out. So let's start by the production, right? So this is the production, okay? It's very similar to the diagram we just saw on PPT. So this is where the transactions, the credit card transactions come in, and it's calling a process, and this process is calling all these things you see here. So the core banking transaction operation is to talk to the legacy, to process that transaction. The data lake to store the final results. The fraud prediction machine learning model to predict fraud. And the whitelist operation is customer services. I'm checking if you have whitelisted that transaction. This process, you can see it here. So I'll try to zoom in. That works? Yeah. So the first thing I do is transform the data that is coming in into features to call the model. So that transformation. So these are the amount of the transfer or amount of the payments, the transfer type, the transaction type, the from account to account. It's a demo. It's very small fields. There's no many fields here, but you got the concept, right? I'm trying to transform all these fields into a vector of integers to call the machine learning model. And this first data point here is a simple number, so I don't have to do anything with it. It's just the value is the amount that is being paid or transferred. The second data point needs a lookup because it's a merchant category feature, and it's a string. You are going to see it. It's a string. And I need to transform it to an integer because a machine learning model will only work with numbers. So there is a lookup table here that IRIS will help me with. We can take a quick look at that lookup table here. So let's open that. So you see here the merchant codes like McDonald's, CVS, I don't know, and the integers that they are being mapped to. So that process, just call that transformation here. And I'm now calling the machine learning model to predict fraud. I'm doing some tracing, and then I'm calling some business rules because the machine learning model will just tell me a probability of fraud, and I have to make a decision, right? So interoperability, build business rules. Let's open that business rule. So this is a very simple business rule. I have two types of transactions. I have a payment and I have a transfer. If it's a payment and the probability of fraud is greater than 50%, I will block that transaction. But if it's a transfer, it's between two accounts on my bank, so I will let it through, okay? Well, if it's greater than 80%. I will block it if it's greater than 80%, the probability of fraud. So what else do we have on that business process? I have a condition here. Is this a fraud? After all, I call the machine learning model, I apply business rules, I can combine machine learning models here, I can call more than one, okay? And the business rules can be used to combine this machine learning model. That's what happens in the real world, in fact. And I can make a decision here. So if it's a fraud, I will call customer services. Has this customer whitelisted that transaction? Is it whitelisted? If it's not, I will block it. If it is, I will let it through. So after all, is it allowed? Can I do this? Yes. So call the core banking system and then populate the data lake. So now let's see that working. So this is my last transaction here. This is the audit trail. This is very, very useful because you can store 6 months, 1 year of data here. And if someone tells you that you did something wrong, you can always search the audit trail and find the evidence that will help you to either confirm it or deny it. So I have worked with a partner, Alumna Health, and they built this nice application to call my demo. And I will try to make a transaction here. So let's buy a McDonald's hamburger. Okay. And let's swipe the card. So that's the transaction coming out. That's the result coming in. And let's see the audit trail. So let's search here. There should be a new transaction. There it is. Let's click on it. And look at all of that happen here. So that's the service, right? And that's the REST call that just came in. And it's a payment, $10 from this merchant, from this account to this merchant. The C is for customer, M is for merchant. Okay. The process starts working. So internally, it called that data transformation and lookup tables. And now I have all my features transformed into integers. And the machine learning model is running. And it gave me a prediction. So there is a 10% probability that this is a fraudulent transaction. So now I can run my business rules, and they are all fine, pass it. There is no problem here. 10% is too low. So now let's call the core system because we have to do this transaction, right? It's not a fraudulent transaction. And I'm sending all this data to the banking core, and it's giving me back a transaction ID and the balances. And I am aggregating all this data and storing it on the data lake. But look at that. I'm giving the response to my point of sale. I'm updating the data lake in parallel. It's happening in parallel. I don't have to wait for that. I have all I need. I will just answer my customer and keep updating the data lake in parallel. So let's do a fraudulent transaction, okay, or try to simulate one. Where was that? Okay, here. So let's try to buy $1,000 of McDonald's, throwing a party for the kids. So that's it. And, oh, it was approved. No, false. That is, declined. So what happened? Let's go again to the audit trail, search it, and look at the last message. It's different, right? So the transaction came in, the process started, the machine learning was called, the model was called, I got a response. There is a 98% probability of fraud, and I talked to the customer services. There is no party going on, so no whitelisting, so declined. So there is all these evidences here. If the customer calls you furiously, like, why are you blocking my transactions or whatever, you can use that to understand what's going on. All this has been stored into the data lake, so the data scientists can keep working on a notebook, a Zeppelin notebook like this, or using Python, using R, whatever tools they like to access the data. So here I'm using Scala with Spark, and I have to, let's just run this. And This is starting the Spark cluster, and not the Spark cluster, but the Spark context in the cluster, and importing all these libraries. The first call is always slow, and after that is done, and there it goes, I will be reading data from IRIS. So this is how I talk to IRIS using Spark and Scala. So I'm doing a select, and I'm joining data from several tables. So that's cool already, because a data scientist will normally ask for a CSV file to be exported from customer service, another CSV file to be exported from the banking core. They will all complain because they're exporting data that is critical, that is sensitive. You know, it's always difficult, and they keep asking this over and over again. Every time they have to retrain their models. It is easy like that. So I cache the data in memory. I have 500,000 records of transactions. Is there any transaction with new rows? So this is how we can look at the data, the amount of the transaction, if it's fraud or not, the merchant, category of merchant, gender of the customer, the age of the customer. I can do some statistical evaluation of the data. There is a function I use here to train the model. I would just skip that. So now it's working, yeah. You see there is a new transaction there because I just did that. So that's the data. I can do, that's the function. I need to run this. I could run the entire notebook, but this is, okay. Did this run? It was very quick, yes. So now I should have the schema. Those are the fields, the features that I'm working with. And I'm dropping some columns. I'm changing the data type of others. I will not spend too much time here. And this is important. I need this vector assembler. And here is where I'm going to train the model. So the decision tree classifier is a machine learning algorithm that creates a decision tree based on the data. And it will look all the data that is fraudulent and not fraudulent and try to build a decision tree to reach the same conclusions. And I'm building a pipeline here. I'm setting the stages, the vector assembler, the chi selector. I'll not spend a lot of time here because I don't want to. Decision tree classifier. And here I am. Let's do this. It's training the model. It takes a little bit of time because it's 500,000 records and it's running. But after it's run, if it's done, it will export a PMML file. You're going to see that. Here it is. So now I have a PMML file right here. And I will just jump quickly to the production here, because I have the PMML file loader. It's a class that I wrote that just imported the model right here. So the production you saw is now operating with a new version of the machine learning model. It's easy like that. I don't have to, okay, here is the model. So what should I do with that? No, that's I'll show you the model. That's the model here. Look at this. Just code that into your program by hand. Okay? You don't have to do that, right? If it's that's an easy model, and that's why people like decision trees, because it's easy to debug. But if it's a linear regression, if it's a neural network, we're talking about hundreds of equations that you have to code by hand. It's crazy. But with PMML, it's easy like that. I can export this as an XML file, and IRIS can import that and apply it to your production, and you're making smarter decisions. You want to take a look at this PMML to see how it looks like? Let's stop that class, that service here, because every time I generate a model, it will take the file, load it into IRIS, and delete it. So I want to show it to you. Let's see here. That's mobile banking. That's where it will appear. Let's go back to Zeppelin. And let's train that model again. I have to wait a little bit, but all this processing is happening in memory. I'm not coming back into IRIS and loading the data again. I load the data only once up there. And now I'm training the model. I'm doing whatever I want in memory. So I'm not hitting IRIS over and over again. So I should have a PMML file here now. Oh, there it is. And that's how it looks like. So you see here that I'm using these features, merchant, category, amount, only these three, to define if it is a fraudulent transaction or not. And all those ifs are here, right? But when I import that into IRIS, it becomes object script. It becomes code that the IRIS can run. I don't have to code it by hand. Okay. So I don't know how much time do I have left. So I think I'm done here. 10 minutes. Wow, I thought that. Any questions? Do you want to see anything more specific? Do you have any questions?
I'm curious as to why in the archiving of the transactions, you do archive the transactions that were not.
It's a bug. You're very, very, very you have a good eye. I thought that you wouldn't see that. If you notice on the message trace, Joe noticed that too, Joe Lichtenberg, when we were recording the video, and I just realized that. But there is no call here to the data lake. If you compare to the previous session, I called the data lake, right? But when it was denied, I didn't. And that's on the process. The process calls a data lake right here when the transaction is allowed, but it is not calling the data lake when the transaction is. I think I should move this down here, right? And let's do that. Why not? Okay, and you can see how we do it, right? That's cool.
You guys must have planned that.
No. No, not really. Okay, let's compile this, and I hope it works. I should never do that. Okay, it's compiled. So let's try that transaction again. And okay, there is a problem. Something exploded.
You didn't start the production.
I didn't?
Yeah, you stopped it.
No, but the problem here is that. Yeah. Let's see the trace. But I didn't stop the production. Maybe I should have restarted the process because I changed it. But no, this service here, I don't need it to be running because it's just loading the PMML file and Yeah. We can look at the message. You're right. I think you're right. We can look this. It's cool because it shows how an error appears on the visual trace, and I think you're right because data type validation failed. I don't have the balances, right? You're totally right. So that's cool. That's what the visual trace is for.
Does it make sense to train using your own prediction of fraud or not fraud? Because you don't know. I mean, if you know that what you think, what has been predicted, probably it would be better to use the actual frauds that has been verified.
No, you were right. What's happening here, I'm not doing that. What I'm doing is that, remember there is a customer services application, right? And the data set has these fraud marks on it because some customer called and told, I didn't do that. That's not my transaction. And that's a complaint on the customer services. And there is an investigation, and then someone, okay, this is really a fraud. And the data is checked. And I have that on my data model here, if you look at the source code. So when I have this, when this works and I store the data on the data lake, you will notice that I don't have the fraud mark here. And because the transaction was done, so supposedly it's not a fraud, up to the point that the customer will call customer services and I will know, okay, this is a fraud. So my model didn't catch it. And then I have to retrain my model considering this complaint from customer services. So that's the reasoning behind it. So that fraud mark is just the conclusion of the investigation that we did as customer services. It's not the, and the in the machine learning model is just trying to reach that same conclusion before the fraud happens. Does that make sense? It's okay? This is all, I built this, I don't know, I'm not a financial services expert, and this is a solved problem, right? But it explains a lot that can be done in many situations, like you're routing a ticket to somewhere, and you're using machine learning to know where to route it to. You are predicting, I don't know, maintenance. I just did a demo of IoT on the other session, and I want to find anomalies on power transformers. It's the same workflow. You know, you are looking at the data in real time, starting workflows, sending alerts, feeding the data lake, data scientist works, feed the model back in, and this keeps going. So, and we can support this workflow very effectively. Okay. It's not yet, but we will be, this is on GitHub, and if you want to send me your GitHub account, I can give you access to it. But we will put this on InterSystems official GitHub. So it will be open for everybody. It will be published on Open Exchange and on the developers community. Well, thank you. Thank you very much.